The mean value theorem problems in the book are pretty straightforward. It's my job to get across to you the ones that are not so straightforward that you will see on the AP exam. Probably 2 out of every 3 years you get some kind of MET free response reference. All right? So, let's start by big picture. Just if you were just to summarize kind of the big idea of MVT, plain old English, give me something. Okay, tangent line, secant line, beautiful. There's a place where the tangent line, secant line slope is the same. What else?
There will be a rate of change that is equal to the average rate of change.
Beautiful. Okay, that is perfect. Those are the big ideas. All right. Now, the execution of those ideas then in table problems, tables present a huge issue because there's so much gray area when tables come along. Before we get to the specific MVT, let's do a little compare and contrast between 3 ideas that almost look identical. You got this little baby table. X is going differentiability, twice differentiable, by the way. I'm going to say that frequently over the course of the day. That means F prime and F double exist for all. That actually implies a whole ton that right there. If F double exists for all, then that means it's the derivative of F prime is good everywhere. So it must mean that F is continuous because it was differentiable to get F double. So you get F prime is continuous and differentiable, which also implies F is continuous and differentiable. There's a lot implied in that. There's a lot of power. You with me? Now, go back. Now we're here. Must there be a place, a C in 0 to 2, I remind you C is an X value, such that F at C is 1? Yes or no?
Yes.
Yes, okay. Or you say no. Must is a very powerful word. Must. Not can, must. And why no?
Because the intermediate boundary theorem doesn't say so.
Yeah, it doesn't really apply here. When we say F at C referring to the IVT, is there a Y value? And I should say, must there be a Y value that's 1? Well, all I have is that it's going from a Y of 5 to a Y of 7. That doesn't tell me anything about 1. It could be. I mean, it could go from 5 down and then back up to 7. So it could be 1, but I don't know. It has to be 1. You agree? Okay. So you would say something like, I don't even know if I would need to say, though F is continuous, I would just go straight to because 1 is not between F equal 5 and F equals 7, IVT does not guarantee such a point. Okay, something along those lines. It communicates you understand IVT and how it works. You with me? All right. So close. I mean, when I retyped this, I just copied it and threw in one little change. Must there be a place 0 to 2? Actually, 2 little changes. 0 to 2, such that F prime at C. F prime at C is 1. Now, if you read F prime, they almost worded the same. But if you read F prime, that's more like instantaneous slope at the point. That's MVT. All right, read carefully. That one little prime is the big difference between the 2 approaches, IVT versus MVT. Well, yes or no?
Yes.
Yeah, that would go to, well, is the average rate of change 1, and therefore guaranteeing an instantaneous rate of change 1. And I think you'll agree that as we find slopes here, you're going to be looking at this change over this change. I know in the table it reads this over this, but really it's changing F, so mentally think this one over that one, okay? So that slope is 1, yeah? So that one is going to be a yes. We start by meeting the conditions. We would say F is continuous and differentiable. It's actually okay to just say differentiable because that implies continuity, and that's accepted. But I'm going to go continuous and differentiable. You could give the intervals, but it's continuous and differentiable for all. So by MVT, that says MVT, there is a C. This symbol is an element of. You can also just say in 0 to 2, whichever you prefer, such that f prime at C is equal to f at, don't go B and A, go specific to this problem, f at 2 minus f at 0 over 2 minus 0, which is, you follow? So that's an MVT with the table kind of approach. One quick side note, and then we'll go back to super MVT practice. Must there be a C in 0 to 2 such that this symbol nonsense? What the heck is it saying in plain old English? Interpret it for somebody who's not a math person. Plain old, what does it mean? Take some thought. I'll give you a second. Hold on. Let's go here. F at C, is that a reference to all y values or a specific y value? Okay, so must there be a specific y value, and then that's greater than or equal to. Now f of x, is that specific y value or all y values? All y values. So they're really asking, must there be a specific y value greater than or equal to all other y values? So what does that mean? A maximum, what kind of maximum? Absolute maximum. This is the extreme value theorem. Okay? This is the extreme value theorem. Do you remember the conditions for there to be guaranteed an absolute max? So you should start by saying, this means, is there an absolute max? Guaranteed. The conditions for absolute max, there are two. Although you can have an absolute max if a function doesn't have endpoints, you won't be guaranteed to have one if it doesn't have endpoints. So if you have endpoints, that's a start, because that eliminates the possibility of it growing forever on the sides or an end behavior. And then you also need continuity to eliminate the possibility of, okay, wise guy, I give you your endpoints, but inside I've got this asymptote, right? But if you have endpoints and continuity, then if you go from one point to the other continuously, it doesn't matter how it happens, even if it's differentiable or not, you have to have a point that maxes all others, okay? So in this case, you would say that f is continuous on a closed interval, because they are giving you closed intervals, there are two. So by AVT, the extreme value theorem, there must be a C where the y at that value is greater than or equal to all other values. Greater than or equal to, because it could be repeated. You know, it could be tied later. Some other point could tie. You with me? Oh, embarrassing.
Someone in Texas.
Really? What do you know in Texas?
I know it was like one of those calls.
One of those annoying calls? Yeah. Okay. All right. The rest of this is all MVT. I just wanted you to be aware of this. Actually, there's a little bit of IVT mixed in. So here we go. These are problems that, with practice, they'll get easier. They're going to involve a lot of writing. Feel free to whine and cry about that. I don't care. I don't hear it. So it's fine. Okay? You'll see that position, velocity, and acceleration are often used for these problems. You can assume that position, velocity, and acceleration are all differentiable. Okay? We don't get into the proof of that. I'll lead Mr. McTells to that. You can make that assumption. So, in this case, I'm giving you position and velocity functions They're both differentiable. Must there be a time when the particle is at rest? Now, I give you this table here, and this is a real gotcha for some people. You've got this table of position and velocity, and at rest, you should start by saying at rest implies velocity equals 0. Well, you've got a row of velocity here. It would be very logical to say, well, looky there. Do you see any places that indicate the velocity is probably 0? IVT stuff. No, I mean, look at it. It's positives, positives. I don't see it. Could it be passing through 0? Maybe, but I don't know for sure from the velocity. Okay, so write that down in your notes. IVT for the velocity doesn't seem to indicate, to guarantee velocity equals 0. And yet, if you look hard enough, you'll see, yeah, velocity has to equal 0. Why? Yeah. Say it again?
You go from 12 to 5.
Yeah, so you're looking here. I agree, you're on it. Give me more. Okay, so let's go here. Forget V for a second. Let's go here. Wouldn't you agree that if we're looking at position going from 5 to 12, then it seems like position is increasing. Now, again, don't read too much in the table. I don't know it moved monotonically or that way the whole time. It could have moved back and forth. But surely position increased somewhere in there. At some instant, it had to have been positive, right? Velocity had to have been positive. And here, as Danielle's referring to, the position decreased. And so if position decreased, surely velocity was negative. Although at those instants, velocity was positive, there's probably some time in there where velocity was negative. So it had to have been 0 as velocity went positive to negative. Now that's where MVT comes in. We're talking average rate of change. Look at these two guys. Same position. What's the average rate of change then over the whole interval? 0. The average rate of change is 0 because the overall net change in position is nothing. So the average rate of change is 0. Now I know it was obviously moving, but overall, net change of 0 means there must have been an instantaneous change. So MVT does prove, will prove, V equals 0. Right? Now, here's where we start to go away from just straight up F every time. You have to use the variables for the problem, and there's no F here. It's position and velocity. So, do I need to state that position is continuous and differentiable, or velocity is continuous and differentiable? Position, because I'm going to take the derivative of position to get velocity. So I need to say position, or x, is continuous and differentiable. So by MVT, the next part is where you make a reference to the time frame you're going to show. There is a time, you can call it t, you can call it c if you like, it doesn't matter. There is a c in what interval am I going to find? 0 to 8, because I need those two 5s to work with. Where or such that x prime at c, which equals velocity at c, is equal to the average rate of change. So talk to me about the average rate of change. X at 8 minus x at 0 over 8 minus 0. The overall average rate of change is 0, so there's got to be a place where the derivative of position, which is velocity, is 0. Yes?
On the AP test, can you cite that the endpoints are equal to each other and then say by Rawls?
Yeah, you could, absolutely. So you could, that would be a slightly different, you would say continuous and differentiable and x at 8 equals x at 0 by Rawls 0, blah, blah, blah. Yeah, absolutely. Yeah. Okay?
So Danielle's original logic, or at least the way I understood it, we didn't even have to think of the x at 0. We knew that x was increasing and then x was decreasing, so we knew v had to go 0. So why did we always have to use the average rate of change?
You do see that's just because the position is increasing here doesn't mean velocity is positive unless you prove it with the MVT. Okay, sure the average rate of change is positive. That just means the average velocity is positive, not the instantaneous velocity is it. So that is positive. So there's really just no way around using MVT. Sorry. As much as I'd like to say position went increasing to decreasing, so velocity must have been 0, that doesn't prove. Okay, would you try these two on your own? Go. Three, four, five. ¿Listos? Okay. Okay. How can you demonstrate that A is 0? I guess you could. Oh, never mind. Go ahead. IVT, yes. What subinterval? First of all, A is continuous, yes. And 0 is between what values and what interval are we going to look at? 7 and 9. A is continuous, and 0 is between -1 and 3. So by IVT, A equals 0 at some time in 7 to 9. You with me? What about A equals 6? Proving acceleration is 6. I think you'll agree that IVT is out, but is there an MVT approach that we can use? Which points? 7 and 9. Yeah, the difference in velocity or change in velocity is up 12 in 2 seconds. So that's a change, an average change of 6. So there must be an instantaneous. So you could say velocity or acceleration is continuous and differentiable? Which one? Velocity is continuous and differentiable, because that's what we're going to take derivatives on to get acceleration. So by MVT, there is a time, or C, in 7 to 9, where, or such that, V prime at that C, which would equal acceleration at that point, is equal to change in velocity, over change in time, which is 6. Are we cool? How's this going so far? You good? Okay. Gradually working harder. You have to sometimes go a little searching around for the right interval to find the instantaneous rate of change. For example, does it have to be a place where the derivative is -2? Tell me one, maybe even 2 places where the derivative might be -2. 2 to 3. I agree, that's -2 change in f over an x change of +1. So that works. So you could say f is continuous and differentiable. So by MVT, there is by the way, there exists the symbol for that is a backwards E. There exists a C in 0 to 8 such that f prime at that C equals f at, not 0 to 8, sorry dummy. I'm dummy, not you. 2 to 3. We? Are you with me?
Yes.
Okay. 3 minus 2 equals -2. Would you bypass the conditions and just tell me, look for the intervals? Where these would happen, please. Yes?
For these, when we state the conditions, do you not want us to say like continuous
The old-
follows in the interval?
If they tell you it's differentiable for all, then it's easier to just go that way. On the homework problems, on the book, I want you to do that just to continuously write it and get in your head. That's a good question. Thank you for asking. Probably could have eliminated this down to maybe just one. It's a waste. Okay, what interval could you go for -1? 0 to 4, yeah, 0 to 4, you're going down 4 and right 4, so that would be a slope of 1, so that would work. 0 to 4 would work. How about a slope of -3? 2 to 4, down 6 over 2, I agree with that. 2 to 4. All right. And I wish I would have phrased this differently. Sometimes you'll see a question of something like, must there be a horizontal tangent? What if it had said, must there be a horizontal tangent? What would that imply? F prime at some point has to equal 0, okay? Now, if you're looking for where is the derivative 0, or Rollet, you're looking specifically for places where y's are the same. So you could actually go with two different places. There, the total average change is 0, and later on also there's an average change of 0. So you could use Rollet on 0 to 3 or 7 to 8. And I remind you, when you use Rollet, you'll have to show three conditions: continuous and differentiable, and the y values are equal at those two. Okay? All right, now let's get funky. It's a little harder here. All right. So, sometimes they don't actually give you the average rate of change is in the table. You can look all day long, but you're never going to find that average rate of change that they're asking about. They're saying, prove there's got to be a place where the derivative is 0. Now, I would normally say, all right, we'll look for places where the y's are 0, but there are none. Does that mean though, that the derivative has to be 0? Well, it can't be 0. You can still prove it. How? Yeah. What do you see about here, this interval versus that interval? Decreasing and increasing, okay? So if f is decreasing, that means f prime has to be negative at some point. Not necessarily the whole time, but definitely at some time. And f is increasing implies f prime is positive, again, if not the whole time, but at least some time. Well, f prime can't go from negative to positive without passing through 0. So, as Justin said, you're looking at MVT twice with an IVT topic. All right? So this will be fun. You'll love it. F is continuous and differentiable. So by MVT, there is a time. Let's call it a, now I'm going to probably refer to at least 2 times, maybe even 3. So I'll call it C1. In what interval? Let's go 0 to 2 first, such that f prime at that C1 equals f at 2 minus f at 0 over 2 minus 0. Now, you could say negative, but it's just as easy to just find the number. So what's the number? What's the slope? Negative 1/2. Okay, so I've established that f prime has to be negative 1/2. All right? When you do multiple MVTs, you do not have to keep saying the conditions. You can say similarly, which is a reference to the conditions are met, and it's MVT still. There is a C2 in, now it's increasing over a lot of subintervals. It's up to you, but I'll just say from 2 to 6. 2 to 6. 2 to 6. You could use 2 to 3 if you like, such that f prime at that C2 is f at 6 minus f at 2 over 6 minus 2. The average rate of change over that is, 9/4? Wait. All right. I've established 2 points in time where the derivative was negative 1/2 and later at positive 9/4. Well, it can't go from negative 1/2 to positive 9/4 unless it passes through 0. So you would have to meet the conditions for IVT. F, do I want to say F is continuous? F prime is continuous. Now I'm trying to show the movement of F prime's values. So F prime is continuous. I say that because F is twice differentiable. F is twice differentiable means that the second derivative is cool. And the second derivative wouldn't be cool unless F prime was continuous to take the derivative on, right? F is twice differentiable. The next condition for IVT is the betweenness component. And 0 is between negative 1/2 and 9/4. So by IVT, there is a time C3 in, here's the bit of a trick. Where is that point?
Between C1 and C2.
C1 and C2, yeah, so between the 2 points I found, C1 and C2, where F prime equals F prime at C3, actually I should say. But, you can do that. All right. Are you following me there? Last but not least, I think this is the last one. You've got this table, and this time they're not asking about F prime, F double. Does F double have to be 0? I'll give you a second to think about that. Why would F double have to be 0? See anything good for me? Where should we look? Or what's interesting to you? 0 to 5. Those have the same y value. If they have the same y value, what does that imply? F prime has to equal 0 in there somewhere by Rollet. What else? 5 to 8. Another place where the average rate of change is 0, so F prime also equals 0 again later. Well, if F prime goes from 0 to later 0, then F double must go through 0s. Rollet applied to F prime. Yeah? You with me? All right then, here we go. Let's write it up. A lot of writing, but get over it. F is continuous and differentiable. Should we go Rollet? Let's do it. And F at 0 equals F at 5. So by Rollet, there is a C1 in what interval? 0 to 5, where F prime at that C1 is given, guaranteed. Okay? Similarly, now, as far as similarly, the continuous differentiable is cool. The Rollet is cool, but I do have to talk about the y's being equal somewhere else. So I need to say F at 5 equals F at 8. So there is a C2 in 5 to 8, where F prime at that C2 is 0. That's the hard part. Now, how do I establish that F double has to be 0? Okay, so F prime, do I say F is differentiable or F prime is differentiable? F prime is continuous and differentiable, or just differentiable. And we're going to go Rollet again, so I also have to say and. Now the equivalence of values condition, what? F prime at C1 equals F prime at C2. So there is a C3 in, by Rollet, I should say by Rollet. There is a C3 in what interval? C1 to C2, where F double at that C3 is 0. Okie dokie. Now, if you like all this writing and thought logical proof, then you should be a math major, because you do a ton of this. If you think it stinks, then you should stop taking math classes about after your sophomore year, because this is all you're going to do after that. Okay? Questions on set 85. Boom. question on the, we get through these, I can show you how you do it in the test. Which one's the greatest digital function?
We've got number 20, number 11.
5, 20, and 11.
5, 20, 11.
17, I heard. 2. Did somebody say 4? 4. 25. Okie dokie, artichokes. Here we go. 5. This. Is it just, hey, Mr. Earthman got a little crazy with the brackets, or does that mean something? It means something. What does it mean? No, not absolute value. Greatest integer function. It's the greatest integer function. You use it a lot in a rounding case. For example, if I said, hey, give me a program that will say how many buses you need for this many people, you need to round it to a nearest whole number. It's used frequently in applied math. So, the picture looks like this. Okay? Now with the graph then, this is an easy question. Prove f is not differentiable at 0. What's the first condition for differentiability? Continuity. Okay, so you would say f is not differentiable at x equals 0 because f is not continuous at x equals 0. Done. That's it. That's it. Okay? You don't need to get into the slopes or the derivative proof or anything like that. If it doesn't meet continuity's case, then you're done. Okay? 20. 20 is, that's a book problem, yes? It's a replacement problem. I see that right there. Oh, goodness, that's a mess. Okay, so you might have had a bit of a problem of thinking, how do I put a hole on top of an asymptote? Yeah. Perhaps? And the answer, of course, is you do not. That's ridiculous. So, when you get a double root, x minus 3, x plus 1, x plus 1, x plus 1. Normally we would pull a common factor, mark that there's a hole at -1, and find the y component to that hole so we could place the hole, yeah? However, in this case, it's a little wacky because after that you still have a problem at -1. Now you cannot have an asymptote at -1 and a hole on it. So the beauty is actually that that hole is gone and it's just gone. You don't need it. You don't need that factor anymore. These two graphs are exactly the same. You can dump it all together. Okay? So with zeros at 0 and 3, you need to find the horizontal or slant asymptote. Slant. Synthetic division or long division, do you prefer? No. 1, -3, 0. I get 1, -1, -4. Are you looking at y equals x minus 4 for a slant? Yes? 4. There's the slant situation here. Sometimes it's awfully hard to get that whole picture on there, and the part of the graph is not very easy to locate or hard to show in the space. The graph, I think you'll find with sign testing, goes something like this. Cool? Okay. 11. Question on 11. All right. You have the function 1 minus absolute value of x on the interval -1 to 1. And the question is, does Rollet apply? Or roll apply? Feels like it wants to be French, so I'd say Rollet, but I don't actually know if that's right. what do you say? What's the graph look like? So V shifted up one and reflected down, yeah? Now, surely the conditions for average change is met, but is there a place where the instantaneous rate of change is also zero? And the answer is no, because it's not differentiable over the interval. So you would say something like, Rayleigh does not apply because f is not differentiable at x equals 0. Okay? And that's it. You don't find a C because there isn't a C. You do not, thankfully. That would really stink. 17. Question on 17.
For 17, I just used a different hue. Like their answers in sign and back of the
So you overworked this bad boy. So correct me if I'm wrong, but you maybe you did this. You pulled a sine off of this and called this sine squared. Yes?
Yes.
And then you called this 1 minus cosine squared. You're going to feel foolish in a second. But that's okay. So if you did that, it's mathematically sound and it can be proven to be equivalent to their answer. It is the same, basically these would switch signs because of the du issue. So did you have something like cosine of the fourth over 4 minus cosine squared over 2? Okay. Your answer is the same by virtue of the constant being different. That sometimes you can get equivalent answers because the constant subsumes within the difference between the two functions. You overworked this because you already had a single one off to begin with, so I think it would have been best to just say, there's my U, and there's my D. I did the same thing the first time I did this problem, so I can't say that I blame you. Okay? Number 2. Number 2. Number 2 is speaking of also problems that kicked my butt the first time I taught this book. I remember my embarrassment at not being able to figure this problem out the first year I taught this. I could not figure out what I was doing wrong until I read the problem more carefully. So, you need to, and I tried to allude to this in my notes, but you need to understand what R represents in the formula. R represents the radius of the bowl, not the water, not the surface of the water, the bowl. And the radius of the bowl does not change. It is a constant. Okay? So when they say the radius is 14 inches, it's always 14 inches. It's not the surface radius. They are also giving you dV dt as positive 1 cubic inch per second. And they want how fast the punch is rising, which means they want dH dt. When it's halfway up the bowl, given that the radius is 14, then the radius going this way would be 14. So if it was halfway up the bowl, then that would imply when height is 7. Yeah? Do you agree? Yes. Okay, then. After that, as long as you remember that R is a constant, then your life is pretty easy. You should not differentiate. You should say, oh, well, if the radius is 14 always, then it goes in. I would love to develop this formula. I would like to know how this formula comes about. I can imagine you can do it by calculus and revolution. That's pretty easy then. dV dH, that's not a time component to this. It's how volume changes as height changes. Nope, I'm stupid. It is a time component because it's related to rate, you idiot. dV dt, volume changes with time. Something like 28 pi h as h changes with time. And again, h changes with time. You're probably good from there. Factor out a dH dt and divide over and sub, or sub and divide over, however you choose to do it. Did I get you going? Okay, 4. Question on 4. Is 4 still a question? Anybody? Oh, yeah. Sorry, there's no play. 4. Got it. 4 is velocity with 2 variables, or 2 unknowns rather, not variables. Acceleration. They give it to you, but I guess I could have found that. Oh, no. Times 4 times A and B. Okay. So my question is, are these going to switch? So will you agree that acceleration is the derivative of velocity? So I need to take V prime to get A. So if I take the derivative of that, from that I can say, I definitely know A is 2, so that's cool. The only thing I'm worried about is the sign issue. It feels like B is straight up 4, not negative 4, because the negative is already there. So take the derivative and then just be careful with the sign. Okay. 25. Question on 25? Wait, no? All righty then. All righty then. So, FG, is that composition FG or product FG? Product FG. FG, the product prime at 1, that means product rule. So maybe F at 1, G prime at 1, plus G at 1, F prime at 1. I think they give you all 4, right? So, print out the numbers and you're good. Would you like to see your test or no? Don't. I don't want to ruin your weekend. They're pretty good. Yes. They're good. Okay. Some people do not want to see them, sometimes, but okay. There we go. Overall, like I said, they were pretty doggone good, I must say. I need these back. Oh, Antonio, would you beat it, please? Or at least step outside, is what I meant to say. Okay. White, what was it, white, blue? White, green? White, green, and gold, blue? Is that right? Yeah. Oh. I haven't decided. I just finished grading these first periods, so I haven't thought through yet or anything like that. I'll think about it if they're awful, but they're pretty good. Yep. I what? Oh yeah, 19S. I'm not sure what I meant there. You could skip it, but some people thought it meant solve it. 19. So if you do that, I'll give it a
Oh my God. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Track and field athletes are needed for this Sunday, February 11th at 11:59 p.m. and no late orders will be taken. So set yourself a reminder. You are required to have at least 2 items from the store, so please be sure to order as soon as you can.
Students, please sign up for 7th hour early today. Do not wait until the end of the day.
Jags, get your tickets to see Big Fish the Musical next week, February 16th and 17th, or February 22nd, 23rd, and 24th. The show starts at 7 p.m. 5 tickets at lunch for $11, $14 at the door. Please come support all the students involved.
Adams State University is offering a free charter bus from Denver to visit their campus in Alabama for their 5th Discovery Day on Saturday, February 17th. If interested, counseling has the details.
Course selection is next week. Counselors will be given classes to go through your course options for next year.
Valentine's Day is just around the corner. Sweetheart Shop is here until February 14th, selling hugs, roses, chocolates, and serenades. Don't miss the booth at lunch.
Girls Mentoring will be meeting today. Please check in with their classroom teacher first, and then come to the large gym for a fun yoga session.
Do you need a place to unwind after a busy week? Come to Yoga Club today during 7th hour and visit E201. You will leave for the weekend feeling calm and refreshed.
Which one was the?
Senior high students want to explore their interests, expand their horizons, participate in the ASVAB Career Exploration and Thursday, February 1:45 to approximately 4 p.m. This career exam is free for interested tests 11th and 12th graders. See Mr. Northwood with questions.
Are you interested in joining the girls' golf team this spring? Not sure if golf is your sport? Come learn what it's all about at a meeting today after school at 2:45 and C100. You better be there.
Okay, last day to come to the Jefferson County Courthouse from 3 to 5 p.m. and watch your Devil Mockpile team properly end the national case in court of law.
Join the festival for students at the Austin Legendary School Day FAQ registration is February 14th. Students take optional they may have FAQ registration through their online college board account or by calling the college board.
Seniors, have you been working on your scholarships? Need motivation? Stop by counseling this Monday during 10th hour so we can help you. There will be a new scholarship to work on or finish what you started. See you there.
Back by popular demand is Saturday, Friday, February 16th, right after school. You can either do the school of mine with 2 fantastic tours, and last but not least is a session of the lawyer in court. You can go behind the scenes to see what really happens at the courthouse. Saturdays are open to high school students and
Junior high students, National Junior Honor Society will be in the cafeteria getting during 10th hour. Please bring in all of your money from World's Finest Chocolate Sale. We will also be nominating candidates for officer positions next year. Anyone who has a conflict, please listen to what we see there.
Varsities at 1 p.m., Safety at 11:30, and L3 at 10. Go down. Also tonight, wish the girls at the Lucky Good Luck at Stanley Lake. And wish the girls good luck at state finals tonight at CMAC. That's all here now. Have a great Friday.
Yeah, so it's. Yeah, I just like misremembered what it was.
Because I just learned for serious and I was supposed to really have it before. Hopefully we can do.
You haven't read it.
Man, I've read some chapters.
Honestly, I've been reading it in class.
But I haven't read up on it. Yes, I was supposed to.
Well, I mean, you're welcome. You know, at the end, it gets, in the hole in the ground.
It gets in the hole.
It gets in the hole.
Which I don't like that. I was like, I give up. I'm just gonna chill in my hole.
It's gonna hide in the hole. It'll be fine.
How
but-
far are you?
Falcone's finished. Hans finished up. He wanted 400.
Wow.
We were like 24, we were like
Maybe almost halfway.
Well,
Wait, what were you guys doing while we were doing these? Yeah, we tried to hold poetry.
Oh, we didn't have it done any poetry. I don't think.
Yeah, so what were you doing before Invisible?
Invisible Man.
Really? You've been
No,
doing
no, it
Invisible
was-
Man since
No, it
January?
was, oh, God, what was it called?
Falcone was like.
No, it's Falcone, it's Invisible Man also.
Yeah,
Oh, okay.
yeah.
Wait, do you want these?
I do, please, sorry, let me.
Oh, and they're just test drives.